Hello, and welcome to this section of the TI-89 Calculator Tutor. In this section, we're going to tackle the topic of how to find the arc length of a curve using the function that's located in the F3 Calc menu here. So if you go down, you'll see we just did Fmin and Fmax. The next one is arc length. Now, if you remember back, we already covered how to find the arc length of any function that we have already graphed in graph mode. So if you're already in graph mode, the function exists inside of graph mode to mark 2 points on a graph and find the arc length there. But if you don't feel like graphing the function or you don't have time, you can use the direct command right here in the command line. So all you have to do is just type in a function, and let's just pick anything, x squared minus x plus 5 or something, and then put comma x, so this is the variable you're operating over, and then you have to give it two boundaries. X is equal to lower bound, x is equal to upper bound. So let's say we're going to do x is equal to 1, x is equal to 5. So what this is going to do is, if you could visualize it, you would be graphing this function, if you could see it on the screen, and then wherever x is equal to 1 is, you put a tick mark. Wherever x is equal to 5, you put another tick mark, and the calculator is going to use the methods of calculus to integrate this function behind the scenes, basically, and integrate along that path and figure out what the actual length is. Doesn't matter if it's curved or if it's a straight line or whatever, the methods of calculus allow us to calculate the length of any curve in the xy plane there. So it's going to do that behind the scenes. So we hit enter. It's going to do that integral behind the scenes, and see, in this case, it presents a really gnarly answer because it's doing an integration, and so it's going to try to keep everything totally exact. Most people probably going to want to see the decimal answer, so just hit the green button, the squiggly equals, and it'll take the last calculation and redo the calculation, this time presenting it to you in terms of a decimal, so 20.52. So that's really about as simple as it gets for that. And there's nothing much else to talk about. We can do another one just for giggles. So we could do, sine of x, let's say, and we can go comma x goes from 0 to, we could do pi. Where's pi at in blue? Right here. So we could put a pi in blue. So this is operating the same way. You have a function over x is equal to 0 up to x is equal to pi, and it's going to basically do an integration behind the scenes to figure out what the answer to that guy is. So just let it think for a second, and it'll do that integration. It'll present the answer. It'll try to keep it exact for you because that's just sort of how the calculator generally operates. All right, so we get an answer of 3.82, and so it just does that integration there and gets the answer back. So that's really all that's for. It's in the calc menu. Sometimes you do need to do that. It's great to go ahead and just check your answers, check your work on an exam if you've done the integral by hand, which usually you'll have to do in your class when you learn how to do this, and check it with your calculator is really great. Now, if you